Welcome back. We've been looking at graphing reciprocal functions, and we've been, in our last video, we looked at using transformations to graph our functions. So we looked at the transformed function is y is equal to a over x minus h plus k, where a, h, and k are actually the same a, h, and k that we've had all year when we've had transformations, but we now have kind of different roles that they have. So we're going to use transformations to graph this reciprocal function. Y is equal to -2 over x plus 4 plus 3. My first thing I want to do is I want to identify a, h, and k. So a is whatever is in the numerator of my reciprocal function. So that's going to be -2. The denominator is x minus h. So x plus 4 means I have an h value of -4. So I have to take the opposite of whatever value is there. And my k value is whatever is not part of the reciprocal, so that's plus 3. The domain of my function should be x is not equal to h, which makes sense because if I plug -4 in, I get a denominator of 0. That's no good. And that domain becomes my vertical asymptote of x is equal to -4. So x is equal to -4 is my vertical asymptote. My range is y cannot be equal to k. So that's y cannot be equal to 3, and that becomes my horizontal asymptote, y is equal to 3. And that makes sense because this value here can't be 0. -2 divided by any number can't be 0. So if this can't be 0, y can't be 3. So here is my horizontal asymptote. Y is equal to 3. Finding my x and y intercepts. So my x-intercept, this is when y is equal to 0. So I will plug in 0 is equal to -2 over x plus 4 plus 3. -3 times x plus 4 is equal to -2. So if you go through and solve that, you get x is equal to -10 thirds. So -10 thirds 0 is 1 point. So that's -3 1/3 0. So that's going to be right there. That's my x-intercept. And my y-intercept is when x is equal to 0. So that becomes, when x is equal to 0, I get y is equal to -2 over 4 plus 3. This is 1/2 plus 3. This is 3.5. So this is the point 0, 3.5. Or this should be -2 up there. So that's -1/2. So this should be 2.5. That makes more sense. 2.5. So I have that point there. So when I go to my table of values, I need 3 points in each region. So I already have over here to the left, I've got -10 thirds 0, and I have 0, 2.5. So I'm going to pick some value in between, like maybe -2. So if I plug in -2, I get -2 over -2 plus 4 plus 3. This is going to be -2 over 2 plus 3. This is going to be 2. So I have the point -2, 2. So I can kind of connect these points here and see that they approach my asymptotes there. And I'm going to pick some values to the left. I'm going to go maybe 2 units away here. So I'm going to go over to, or let's go over to -5. If I plug in -5, I get -2 over -5 plus 4 plus 3. This is -2 over -1, which is 2. So I'm going to get the point -5, 5. Should be up there. If I go -6, I should get -2 over -6 plus 4 plus 3. This will end up being positive 1. So I'll have the point negative 6, 4. And maybe I'll go with negative 4.5. So that'll give me negative 2 over negative 4.5 plus 4 plus 3. This is negative 0.5. Negative 2 over negative 0.5 will be positive 4. So this will be 7. 3, 4, 5, 6, 7. It's going to be about there. So this graph looks like that. So let me just graph this over this in orange. And if I look at my value of A, my value of A was negative, so I expect to be in the bottom right and top left quadrants, and I am there. If you get anything that doesn't look like you expect it, if you've got values to the right of your asymptote, both below and above this horizontal asymptote, you know you've made some type of math error and you need to fix it or check into it. Same thing with on the other side. If you start to get a graph that doesn't look just like this, something's gone wrong.